Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 6 problem of this month on LeetCode. Before starting, if you guys haven't subscribed to my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3607. Power grid maintenance. Right. So in this problem, you are given an integer C representing C power stations, each with the unique identifier ID from 1 to C. So it is nothing but bun based indexing, right? And these stations are interconnected via n bidirectional cables represented by a 2D array connections where each element connections of I is equal to U V indicates a connection between a station U and a station V, and stations are directly or indirectly connected with a power grid, right? And here it is saying that initially all the stations are online operational, right? And you are also given a 2D array queries where each query is one of the following two types. So one is this and one is this. So here if you see, this is starting from 1 and this is starting from 2, and here we have some x value, right? So if we have query like this 1 and then x, so that simply means a maintenance check is requested for a station x, and if station x is online, then it resolves the check by itself, just return the value of x. But if station x is offline, then the check is resolved by the operational station with the smallest ID in the same power grid as X, right? And if no operational station exists in the grid, then we have to return -1, all right? And here, if something like this, if our query is like this, 2 comma x, then in that case, station X is going to go offline. It becomes non-operational, right? And in the end, we have to return an array of integers representing the results of each query of type this 1 comma x in the order they appear. Note, the power grid preserves its structure. An offline, non-operational node remains part of its grid, and taking it offline doesn't alter the connectivity, right? So let's understand this problem statement with an example here. So here if you see C is equal to 5 and it is a bun based indexing. So I can say 1 to 5, 1, 2, 3, 4, 5, right? And here if you see connections, so 1 to 2 there is one connection, right? 1 to 2, then 2 to 3 there is one connection, 3 to 4 there is one connection, and 4 to 5 there is one connection, right? Clear? Now what we need the result for queries like this which are starting from 1, right? For this one, for this one, and for this one. So that is why you are seeing the output size 3, right? And now here let's see this query first. All right, so 1 comma 3, so 3 is online, right now all are online, right? So 3 is online, so 3 is going to resolve it by itself, right? So query 1 comma 3, station 3 is online, so the maintenance check is resolved by station 3, right? Done. Then here if you move to this query, right? So 2, that simply means that this value 1, right, this station, it should go offline. So station 1 goes offline. The remaining online stations are 2, 3, 4, 5, right? And all are connected right now, right? All are connected, right? And this is one single component. This is one single component, right? Single component you have as of now, right? And after that, if you go here, 1 comma 1, so station 1, you know that it is already offline, right? So station 1 is offline, so the check is resolved by the operational station with the smallest ID among 2, 3, 4, 5, right? So 1 is part of this complete component, right? 1 is offline, and now remaining are these 2, 3, 4, 5. Among them, smallest is 2, right? So we have to return 2, right? So I can maintain all these values in one tree set, right? So it will be in sorted order, right? Everything, so I can maintain that, right? I can easily fetch the smaller value because smaller value is going to be always first, right? So first value is 2, so I'm returning 2 here, right? We will discuss it further. Okay, then here 2 comma 2, 2 means this operation 2, that's it, means for this 2, this 2 is going to go offline, right? So station 2 goes offline, the remaining online stations are 3, 4, 5, and if you see in this set, reset, this is a smaller value, right? Next time, and here 1, 2, so 2 we need to fix. Station 2 is offline, so the check is resolved by the operational station with the smallest ID among 3, 4, 5, which is station 3, right? So we have to return 3 here. That's it, this is what we need to do, right? So since this problem is dealing with the components, right, and there are connections, right? So we are joining the stations, right? There is a connections between them. and there if there right now, if you see, there is a proper link between all these stations 1 to 5, right? So this is one single component, but there may be case, right, when there is not only one component, right? Here if you see in this example, c is equal to 3, right? C is equal to 3, so I can say here I have three stations, 1, 2 and 3, right? And now after that, if you see, there is no connection, right? There is no connection. So in total, if you see, this is one component, right? This is one component, and this is one component, right? There is no connection. There is no connection among them, right? And queries here, it is saying 1 1, right? So 1 1, initially our are online, right? And first query is 1 comma 1, right? So we have to return some output for this. So this station is online itself, so I can return 1 here, right, for this one. Next is 2 comma 1, 2 comma 1. For this one, I don't need to return any output, right? But here this station 1 is going to go offline, close it. Then 1 comma 1 again, 1 comma 1, right? So now 1 comma 1, it is saying 1 is offline here, right? So we need to resolve it by finding the minimum, but there is no minimum here, right? So we have to return -1, right? So 1 and -1, right? So see here, 1 and -1, there are no connections, so each station is its own isolated grid, right? Single components, right? But here if you see in previous example, so only single component was there, right? But here we have three components, right? So query 1 comma 1, station 1 is online in its isolated grid, so the maintenance check is resolved by station 1. Query 2 comma 1, station 1 goes offline, and query 1 comma 1, station 1 is offline, and there are no other stations in the grid, so the result is -1, right? Clear? And here if you see the constants, so constants is like this, right? So c value from 1 to 10 to 5, this is also huge. Connection side length is going to be 2, and v values we have, queries dot length 2, queries of I of 0, right? It's either 1 or 2, right? This is given, and that's it, right? Very simple, right? These are the constants, right? So now here if you see this problem, in this problem we are dealing with the components. We are getting these components by making the connections, right? So we are doing the union among them, right? We are doing the union among them, right? If there is a connection between station 1 and station 2, then we are connecting them, right? Then they are going to become one component, right? So we are going to do the union, right, among them. Okay. And initially before giving these connections, all the stations are individual, right? C5, that's it is, we have stations like 1 to 5, 1 2 3 4 5, right? Initially like this. After that we have connections, right? So we are, after that we are going to make the connections, right? But initially all are single components. Initially all are single components, right? Initially. Okay, so I can say that for this station, the parent is this station itself. For this one, the parent is this station itself. For this one, the parent is this station itself. For this, the parent is this station itself. For this, the parent is this station itself, right? Now after that, right, after that, here if you see, you are doing the connection between 1 and 2, right? 1 and 2 you want to do the connection, right? 1 and 2 you want to do the connection. Okay, so now in this case, see, parent of station 1 is 1, and parent of station 2 is 2 initially, right? And when you are planning to do the connection with them, right, so we have to find out a single parent for them, right? We have to find a single parent for them, right? So that simply means we have to do the union among them, right? And here I'm finding the parent of these two stations. So from this it is already clear now that whenever I'm discussing about components, right, or this stuff, right, components, so definitely DSU should come to my mind, right? That is nothing but union find data structure. So this is what I'm planning to use for this problem. Disjoint set union should come to my mind when I'm dealing with the components, right? So now here if you see what I'm planning to do, okay, so here 1 and 2, right, 1 and 2 both are having different parent, but when I need to join them, when I need to do the union among them, so I have to make any one component as one parent, right? So let's say I join them, right? And let's say one is the parent. Okay, one is the parent. So for representation, I'm going to show it like this, let's say. Okay, just for representation, 1 and 2, like this, little bit here, right? So now parent of 2 is also 1. I make the parent of 2 equal to 1, and parent of 1 is 1, right? This is what I did, right? Okay, clear. Now after that, if you see the problem statement, we have to join 2 comma 3, right? Then so 2 comma 3, right? So 2 comma 3 I want to join, right? 2 comma 3, right? So here parent of 3 is 3, right? Parent of 3 is 3. Parent of 2 is not equal to 2, right? Parent of 2 is not equal to 2, right? Parent of, because parent 2 is 1 now, right? So in that case, what I'm going to do, uh, in my data structure, when parent of 2 is not equal to 2, so after that parent of 2 I'm going to operate as, again I'm going to find the parent of this 2, right? Again the value inside this, right? So value inside this, it will be 1, right? It is 2, but the parent is 1, right? So for this 2, what is the parent? I'm going to search for that. So it is going to reach here, right? And I will get the 1 as parent. Okay, so I will show you with code how I'm going to do this, but as of now let's understand parent of 2 is 1, right? Clear? Okay, so root of 3 is 3, right? 3, and root of 2 is 1, right? So now I have to join them, right? I have to join them. Okay, so this rank of 1, right? What is the length, or what is the total rank, right? What is the height of this? You can say height is 2 and height of this is 1. Only 1 is there, right? Only 3. And here rank of this one is 2, right? I'm checking for this one because this one is the root of this 2, right? So now how I'm going to join them? How I'm going to join them, right? So I can join them like this, 1, right? So rank of here, if you see the rank of this, rank of which one is smaller, right? So rank of let's say this is smaller, right? This is smaller, right? So then parent of this I'm going to make what? Parent of this I'm going to make as 1, right? So I'm going to connect them like this, 1, 2 and 3, like this I will connect. Okay, same way for 4 also I'm going to connect here, right? 5 also I'm going to connect here. I can connect them like this in a long way, 1 2 3 4 5. See, but the height is very big, right? Searching will be complex here in this level, and then from this level this, that's it. Okay, so I can easily search. So you can use this or you can use this, your choice, right? But I'm planning to use it like this. Okay, so that performance is going to get improved if I use this approach. Okay, if I'm using the rank in DSU. So this is one another topic, rank in DSU, right? So this is what I'm planning to do. Okay, so now let's say I have created like this, 1, then 2, then 3 here, then 4 parent is this, then 5 parent is this. Okay, once this is done, now after that what I need to do, what I need to do here, we have to process the queries, right? So here these are the queries, 1 3, right? This 1 3, all these queries we need to process, right? Okay, so now what I'm going to do here, okay, now what I'm going to do here, let's see. All right, so here we did all this, right? Now after that I'm going to create one tree set, right? So here see, for all these there is one common root, 1, right? Only one common root, right? So for this one, right, I'm going to add 1 2 3 4 and 5, right? So 1 is nothing but the root, and with this root I have all these values in my tree set. This is what my tree set, I'm going to create it like this. Okay, this is my tree set. All right, clear? So now it is very easy, right? To find the root. So it's not like first 5 and then after that I go to 4, then after 4 I go to 3, then 2, then 1, and then find out that 5 root is 1. But here if I create my structure like this, I can easily find the root of 5 as 1. So this is the benefit that I'm talking about, right? Very fast. So for all these nodes, the parent is root is 1, so I'm adding it 1, and the root is 1. Okay, 1 for 1 also, root is 1, right? This is done. Now after that I have to process this 1 comma 3. Okay, 1 comma 3, right? So 3 is currently online, so I'm going to return 3. 2 comma 1, So 1 I'm going to make it offline. So if I'm making offline, I'm going to remove it. Okay, if it is offline, right? So I'm going to check if type is equal to 1, if type is equal to 2, if type is equal to 1, if type is equal to 2, if type is equal to 1, like this I'm checking, right? Okay, so if type is 1 and I'm checking that if it is online, then just simply return that. Otherwise, what you need to do here, let's say I move here. So if it is online, then I'm going to make it offline, right? I'm going to remove it from this, right? From this I'm going to remove it, and uh, here I'm going to move it. That's it. Okay, now after that, when I move here, so here I will see that this station is offline. So if this is offline, then for this one, root is 1. So that first I come to this root is 1. Now for this root, this is my tree set. From this tree set I already removed this one, so I will check if tree set is empty or not. Not empty, good. It is not null, good, right? So that's mean we don't need to return -1, right? So we have to just return the first value is 2. I'm returning that. Okay, done. Then after that, here I'm going to remove it. Then here I reach, so 2, so 2's first 2's root is 1, right? I'm going to search this one. In 1 we have this reset which is not empty. First is 3, so return that, like this. Okay, so this is what you need to do. 3 2 3, that's it. Okay, so very simple. I'm going to write the code now, right? And if you guys have clear idea of this DSU, then it's very good. But otherwise, just practice it, this topic. I have solved many problems using this in the past as well. Okay, so very easy, nothing complex. Okay, so here what you need to do, first create one class union find, and here inside this, first for the parent, okay, parent, and here rank, and then after that public union find, right? Constructor I'm creating. So in this I'm going to pass the size, right? And here you know that it is bun based indexing, right? So here I am going to write size plus 1 because of that, right? So here just write just write size plus 1, done. And same thing here for rank also, you need to write new int, and here size plus 1, right? And then here after this you have to write for int I is equal to 1, I is less than equal to size, and here I plus plus, and here you have to write parent of I is equal to I, and here rank of I is equal to I, done. This is what you need to do. All right. And after that, how your find logic is going to work, right? So you have to write it like this: public int find. So in this we are going to find the parent, right, of any value, right? So here if parent of u, right, if it's not equal to its own parent, right, parent of u is not equal to 2, then we have to again do the search, right? Then parent of u is equal to find, again I'm calling this find method, and this again I'm passing the value of this parent of u, right? So in this way I will just reach to the top, okay, reach to the parent. And otherwise, if parent of u becomes a u, right, then for that particular u I'm just going to return the parent of u value. That's it. So this is how we used to write this. Okay, this is same structure where that we need to use whenever we are going to plan this DSU, okay, disjoint set union. So we have to write the same find method everywhere, okay, for all the LeetCode problems or any problem coding problem which we are going to implement this DSU. You have to write the same thing for find and same thing for union. Okay, public void union. So union we are just going to do between two parts, so int u, right, and int v, two values, right? So here first we have to find the root of both, right, and then we have to merge the root. Okay, root of u is nothing but find of u, and int root of v is nothing but find of v. And here if the root is same now, if root of both of them are same, then there is no need to merge, right? So you can simply return from here. All right, and here, if now I don't want a tree of big height, right? So for that purpose I can simply use this rank logic, right? If you want you can skip it, but performance will be reduced then. Okay, so here you have to write rank of root v, and here inside this parent of root u is equal to root v, root v. Okay, v is capital. Done. All right, and here else if, and here let me just copy this. Okay, and here inside this, if rank of root v is less than rank of root u, right? In that case you have to update the parent of root v equal to root u, right? And in the else part, right, if same, then you can simply do one thing, parent of root v, you can just update it with the root, your choice, you can change the order as well, right? Based on that you have to update the rank. Okay, so root of u plus plus, right? Because I'm making the root u as a parent, so definitely one node I'm adding below it, so rank is going to be increased for this one. Okay, so this is done, right? This is what we need to do here. That's it. So this is a common code. Okay, now we have to go over these process queries one by one, right? So first, what is my class? My class is union find. I'm going to create the object of this class, so let's say uf, right? And here new union find, and inside this what I'm doing, this is my constructor, right? In this I'm just passing the site, so c value, so here I'm passing c. Done. And then there then I'm going to do all this stuff, right? Find and union, I will do everything. Okay, how I'm going to do the union, right? Find I will do, but union, so for I have to iterate over all these connections one by one. So here I'm just going to write for int count in this connections, right? So here we have to write uf dot union, and here con of 0 and con of 1. All right, this is done, right? And then after that we have to create one map, right? So in map what I'm planning to do, like for all the roots, what are the different tree sets? Okay, so just like this, for one we have all this value, so I'm just going to create a map for this. In this we have tree set, and here we have integers, right? So this is what I'm trying to do. So map of integer, and here tree set of integer, right? And here online grid is equal to new hash map. Done. And then after that we have to just iterate over all these y1 y1, int I is equal to 1, I is less than equal to c, and here I plus plus. And now inside this, first just find the root, right? So root, how you're going to find this union find object, from this I'm just going to call the find, right? And I'm just going to do I of this, right? So for this particular station I'm going to find the root, right? Now I have to check if this root is available with me or not. If not, then I'm going to create a root, right? If it is there, then I have to just simply add the values like this one I want for this one, right? So if there's any other root I find, like say 6, so for 6 I have 6, then let's say 7 is correct, 7's root is also 6, so I'm going to add this 6 to 6 here like this, right? So this is the plan. Okay, so here this online grid, so in this online grid map, right, just check if the key is there or not. Which key? Root key, right? So here put if absent, so key is nothing but root. So if this root key is absent, then we have to create a new tree set. Okay, so I'm just going to create a new tree set. All right, so I have created a new trace set. Now in this tree set, the new tree set that I've created, or the old tree set that I already have, right? So I have to add the value. So online grid dot get that particular root value, okay, go there and add the new value of this I, okay, like this. That's it. Okay, done. This is done. Then initially I'm saying that all the stations are online, right? So boolean is online is equal to new, and here boolean, and here you have write c plus 1, clear? And here you have to just fill all with the true. Arrays dot fill is online with true value. Done. And now result, you okay, result you have to create for result, okay, final result, just create one array list. Result is equal to new array list. Done. Okay, so now here, now we have to just iterate over the queries one by one, right? Final step, we have to iterate over all the queries. So here you can use enhanced for loop again, for int query in queries, right? And now inside this type, okay, based on type you have to do, right? So type in query of 0 we have type, and x value is nothing but query of 1. Simple, right? So now here if condition, if type is equal to 1, right? If type is equal to 1, and now we have to return something, right? So here if first check if it is online, right? If is online, what is online? If is online, the x value, right? So initially all are online right here. So if is online x, right, then I'm going to just do result dot add x, so right, x, done. But if it is not online, right, then first thing, find the root of this. Okay, root is nothing but union find object. For this object, call the find data structure, okay, find method, and find for this x. So we will go to the root. Once we go to the root, right, so what I'm going to do, I'm going to search a smaller value, right? So tree set integer, I'm going to create one tree set, let's say online set integer, and online set is nothing but, so this is the online grid, right? Online grid. So here online grid dot get for the root, okay, for the root I'm creating one online set, right, with all the values. So online set is nothing but this part, for this particular root, this part, okay, this part. Now in this part I'm going to check if online set is equal to null, okay, if it is equal to null, or you can say online set is empty, all right, is empty, right? In that case you have to just return, you have to return something, right? So you have to return -1 in this case, right? So maybe we don't have any online set, we don't have that particular root, right? Okay, or maybe all the stations are closed, empty, right? There's nothing online, right? So this is what we need to do, right? And here in the else part, what we need to do, we have to just add the first result dot add online set, online set dot first, that's it. Okay, and here this is done, this is done here, okay, and this is done here if type is equal to 1. Now else if type is equal to 2, right? So in that case first we have to check if is online, right? So here I'm going to write if is online x, right? In that case this is online x, right? We have to close it. So is online of x, I have to make it false. Then we have to remove it from the online grid, right? So first here what we need to do, we have to find the root. So int root is nothing but union find dot find x, right? And then what I have to do, so I have to go to the online grid and I have to get the root, okay, I have to get this root, and from this root I have to remove this x value, right? Remove the x value, okay. This is what I have to do, right? And that's it, that's it, this is done. Now in the end, whatever the values in the result array list, because we have to return the array, right? So just convert it to array. So that's what I'm going to do now. Int ans is equal to new int, and here you have to write a result dot size. Okay, done. And then here for int I is equal to 0, I is less than result dot size, and here I plus plus, and here answer of I is equal to result dot get of I, right? And then here we have to simply return answer. Okay, that's it. We have to return answer. Done. Right, now let's run it. Okay, so here online set here L. Okay, now let's run it again. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And here can we ignore this online set is equal to null? Let's see. Let's submit it again. So yes, we can ignore, right? Because here if you see, definitely we will have the online set, right? Because definitely we will have that particular root, right? So that is why it is not required. Okay, only we need to check if it is empty. Only in that case we have to return -1. That's it. Okay, so this is a code, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.